All right, how's it going, everybody? We'll give it a couple more minutes here, maybe seconds, just to let people roll in online, and then we'll get it started here while we're waiting. My name is Jason Buck. I am a business development director here at Lean TECHniques. We've have the fantastic opportunity to have our AWS partner here with us today. We are a software and business consulting firm. We are we really help organizations take technology from a cost center to a competitive advantage. And the way we do that is by partnering with our clients in the areas of software delivery, cloud, AI, project management and design, IT strategy, and leadership. So we work closely with the engineering teams at our partners, usually embedding alongside them to try to upskill and help them along, and actually work our way out of a client by getting them the education and the insight that they need. We work with leaders across all industries, financial services, agriculture, manufacturing, building goods, retail, and more. And we're just really help them rethink how they deliver value to their customers and to the business. Also, we are hiring immensely right now. We are in need of engineers due to a ton of growth that we've had and a lot of openings and growth at our clients. So if you are looking to make a change and join a very employee-centered company, please check out Lean TECHniques. 98% of our folks that we have here are actually full-time employees. So it's kind of a nice benefit. You get to work with a lot of different clients, see a lot of different projects, but you have that security blanket of being a W-2 employee as well. So if you're interested, let us know, visit our website, apply, and Emma, our rockstar recruiter, will reach out to you. Quick housekeeping, if you have any questions throughout, just drop them in the chat and we'll try to address them at that time. We don't get to them, we'll try to get at the end, we'll try to revisit those and get some answers for you there. With that, I've done enough talking. So I'm going to introduce what I'm affectionately calling the Italian duo here with Josh Angolano and with Lean TECHniques, our senior professional software consultant engineering lead here, and our AWS senior solutions architect and partner, Fabio Torchetti. Go ahead, guys.
Thank you.
So here's a rough idea of our agenda. We're going to give some background, go over Amazon Bedrock. I don't know if anyone's familiar with that. If you're not, ask questions, as Jason said. Talk about Nova, some new models that Amazon came out with. Talk about Guardrails, some new features, model distillation. Talk about agents, and there's a few more things at the end. So here's some background on AWS, and Fabio probably can add a lot more color to this than I can. They've expanded their AI capabilities. They're making it easier for companies to get AI out of the box as opposed to building your own.
And yes, I've seen many customers try to re-implement the same simple architecture. Like if you think about a retrieval augmented generation, or RAG architecture, people look at the textbook and the slide, they start building their own. And as you start digging into what are the actual needs of a RAG, and you go like, okay, how are you doing your chunking? How are you ensuring that the users get answers from documents they have access to? You start feeling the cracks and you start realizing that creating an architecture that satisfies those requirements is slightly harder than you thought when you saw it on that slide now a year and a half ago, probably. What we're trying to do at AWS is to basically help you build either your own architecture with very simple Lego blocks that go all the way down from, hardware that's made for running this inference, like think about our inference and Trainium chips, all the way up to fully made services that you can use. Think about Q for Business. You pointed to a set of documents you have sitting in an S3 bucket in a SharePoint website, and you can immediately start building applications based on those without having to think about all the details of the architecture. So what we have done in the last year, and a lot of the announcements in reInvent, were just this, giving you a large set of tools that go from very elementary building blocks, and those are all the different Bedrock services we have, all the way up to ready-made business applications like Q for Business or Q for Developer.
So Fabio mentioned Bedrock a little. This is a foundation service that allows you to use foundation models or models that have already been trained on large data sets. So you're not having to train a model from scratch. You can use it for RAG, as mentioned, where you're augmenting it with your own data. Furthermore, you can then build agents and have that interact with your other AWS services from Bedrock.
Yeah, and again, so Bedrock is the simpler part of the building blocks you may need. We mentioned here, you can get from simply doing inference of different models. We host a variety of models you can run. Now we give you also the chance to run your own open source models that you can import and run in a fully managed service, all the way down to implementing your own knowledge bases or your agents or your flow of agents. We're going to see some of the demos here. We're trying to make this presentation as demo forward as possible, just to give you the idea of the art of the possible, what you can actually do with these tools.
So the other thing that was released as part of Bedrock is the Nova models. These are models that Amazon has released for, these are foundation models. They are in some cases cheaper than some of those larger model or some of the other models like OpenAI's. They're tuned for the architecture.
And the idea of the Nova models, we created a whole family of models under the name Nova. You have from very small text generation models to larger multimodal models. So you can have Nova models that can look at pictures, understand audio. We then have announced art generating models, so Nova Reels and Nova Images to generate images and videos. And just a while ago, we announced Nova Act, which is a model and a framework to actually use Nova to build your own agents and tools. And we also announced Nova Sonic. It's a fully speech-to-speech large language model where you actually can process audio and speech, and you get speech generated from the model without having to go through a process of going speech to text, generate the answer, and then get your text to speech at the tail of end. These models listen to audio and generate audio natively.
Yep. So we have a demo here of the Sonic model.
And as Josh is setting it up, so the idea of this model of, yes, we have a question.
Yeah. So when you, how different is Nova than the other foundational model?
Radically. It's a completely redesigned architecture. So first of all, under the umbrella Nova, we now have several models that go from, you have the Nova Express, so we have smaller models that can be used, for example, for powering agents. These are models that are made to have low latency. Compared to the Titan models, there is, a year and a half more of research and training on top of these new models. So I always invite people, never trust anything that comes out of my mouth, right? You look at me, you go, this is a salesperson, never trust. My recommendation is you can have this model, they're very cheap to run them in the console, right? In the playground, and compare how do they work for your prompts, for the kind of workloads you're trying to do. You'll be surprised for how able these new models are. And I think that the other interesting part on this is that the Nova models, being a family, can cover different parts of the needs you may have. I always make this example that, we have had a push for a long time as we started Gen AI. People wanted bigger models, like, oh, yeah, no, I need a larger model to do this. And when you look at what people are doing with these models, like think about retrieval augmented generation, where you're taking a piece of text and a question and you're asking model, hey, what's the answer to this question with this model? A very small local model could probably do 90% of those use cases, right? So, and that's the way we thought about the Nova models. We have very small, agile, low latency models that you can use as coordination. So if you look at the Nova Sonic, for example, this is a speech-to-speech model. In itself, it's a small model. It has a very low latency, But the killer feature of Novasonic is its ability to call tools. So it can actually use smarter, larger models to execute more complex operations while interfacing with very low latency with the user that's calling it in.
Marty, I just notes.
Yes, go ahead. And so we'll see, Josh. So this is one of the examples that comes straight out of the Nova models repository in GitHub. All of this you can find in AWS examples. And we're all hoping that audio works in this WebEx, because otherwise it's going to be very boring for people watching from home. Yes?
That's a quick question. So when you talk about the other models being smaller,
yeah,
is that their total, I guess, neural net size is smaller?
Yeah. You touched two very interesting arguments. When we talk about smaller models, right, we often refer to them in terms of parameters. Just today, I was, by the way, giving a talk where people looked at me and was like, okay, can you explain what's a parameter, right? So when we talk about smaller models, we think about in terms, if you look at a very simple neuron, right? So the idea is that you have a weight, a bias, and that's how you calculate something coming in. The larger amount of neurons, of these weights that you have, the larger these models are. In scaling this model, we have seen that increasing the number of parameters, so increasing, as I said, it's not technically correct, but imagine the number of neurons in these models. If you look at the actual schema, right, at the way these models work, they are very simple architecture and they're all the same. What changes is the size of the architectures and the number of weights they take in consideration. So smaller models simply mean smaller number of parameters. So same overall architecture, right? You're thinking about multi-head attentions, a couple of MLT mixers in the middle, but the architecture are very similar. Is the size of those networks that increases, and with that comes, more memory, more necessity to have high processing powers. So when I say smaller models, lower number of parameters. So you can think about models that have less neurons, and we all know that we can imagine that smaller brains, of course, means that are not as able as bigger brains, right? So, Josh has a very big brain. You can't compare it to me, right? I'm not that smart. And same thing is with model. When you think about size, think literally about the size of the brain. People probably are reeling in their chairs when I'm saying this, but it's a very good way of thinking about it as a mental framework. It's not technically correct, but as a mental framework on how to think a model size is exactly, imagine the size of the brain.
That's a fun one. Glad you. Me too. Absolutely.
Now, what you're seeing here is the Nova model running. The problem you're seeing here, by the way, it's an interesting one. The Mac as the mic, especially in the laptop, as the mic and the speaker too close to each other. We recommend running this as an example in your headphones, so it's actually trying to answer itself. But I just want you to listen to the kind of voice. So if you just started. Hi, how are you doing today?
Hey there, I'm doing great.
I want you to listen to how natural the voice sounds. And these voices are the importance of fully multimodal models like this one where you have speech in, speech out, is the ability to influence the response from the tone of your voice, right? Because tone is meaningful. It's how we carry irony. It's how we carry the fact that maybe a customer may be slightly upset about something when they call the call center, and all of that context would get lost in the classical speech to text, text to model, model to text, and text to speech. So for example, if I whisper to this model, you stopped it. Hello, we need to whisper because otherwise people wake up.
Let's keep it.
You see how he started responding by whispering? So this is the importance of these models, right? Because when we talk in our speech patterns, we carry information. the ability of training and using models that use the natural voice and understand the tone of your voice and can actually respond with a tone that's similar to your voice, it's fundamental. Thank you.
Me too. Glad to hear. Your
Demo effect at its best. So this was the Novasonic, and if you think of the applications of this, right? Again, this is not a very smart model, right? So in terms of, it's not a large model, but it's smart enough to understand what you're saying and call tools. So where today, most probably in your call center, you have the regularly done, you have your utterances and speeches and menu, all of that can be replaced by this model because they're smart enough to know, first of all, from the call, who you are, and then you can talk to them and they can decide which tools they need to call to give you answers. So you can get complex answers done by other models that are actually called by this one, while keeping the context and the tone of the conversation that the model brings in itself. This is available right now. We have a whole set of examples. My recommendation, again, play with these things, because as you play with them, it's gonna make you click and go, ooh, aha, I see what I can do with this now.
Yeah, and you can train, since it's one of those foundation models of Bedrock, you can train it on your data, like,
Yes.
and you can ask it all sorts of questions in natural language.
Yes.
So the other thing we talked a little bit about was RAG, and this is where you're using your data not to train a model, but you're using your data as context for the model. So I wanted to give a quick demo of RAG and how you set it up in Bedrock. It's very, very simple. But to Fabio's point, there's also a lot you need to think about. Security, you need to think about access, you need to think about the context of which you're asking questions. So there's a lot more that goes into it than this, but to get started, it's very easy and to play with these building blocks that Amazon has created.
And while Josh is setting the demo up, I'm going to ask a question. Why do we prefer RAG over fine-tuning a model? Let's imagine that it was very, very cheap, fine-tuning. It's not only that. I always tell people, think about this. When you're fine-tuning a model, the smallest model that you can think about has seen petabytes of data, right? Think of any use case, how much documentation you have. For how much documentation you think you have, you don't have enough. So if you're trying to fine-tune is very good for giving a tone to the model so that it sounds like the documentation you have. And that makes sense if you have a uniform tone in your documentation. But if you're trying to fine-tune to add to what we call the parametric memory of the model, so the facts that the model don't know itself, you end up in one of two situations. You don't have enough data to make a meaningful impact, or if to have an impact, you decide to increase the knob of the learning rate. So basically, as you're training the model, you're telling the model, hey, forget about everything else you've seen. This data is very important. And now what happens is it may be very good at your subset, but you lost the generalization that these foundational models have. So RAG is not only cheaper, it's actually the best way to use models. You can use open source model, you can use our own models, you can change your parameters, but they are relevant to your data and they can be updated in real time. Even if fine-tuning would be free, the benefits you get from RAG you would never get from fine-tuning itself.
So in AWS, this is the Bedrock console. Under knowledge bases, if you go down here on the left, you'll see that you have the ability to create a knowledge base. You literally click on this and there's several different options about how your data is stored. For this, I would just use the default, take a vector store, give it a name, give it some IAM permissions, and then we can choose where that data is coming from. Is it S3? Is it a web crawler? Or do we have some custom source? SharePoint, Salesforce, and Confluence are all in preview. So if you have intranets within there, you pull those up, you click next. It's going to ask you some configuration settings. And then it's going to walk you through some processing. And then what it will do is it will attempt to sync to your data source. So what I've got here is a pre-built knowledge base. I have an S3 bucket here, and basically you can see the last time I synced it, it's been a while. It's got one document in there, but now that knowledge base can then be used inside of my models as a RAG source.
And again, all the infrastructure you normally would have to maintain yourself for creating this RAG is completely managed for you. And you have two options as you're creating this knowledge bases. You can either use existing vector compatible databases. Say, for example, you already have an OpenSearch, you have a Postgres with the vector, or you can simply say, you know what, create a completely new one for this specific knowledge base, and you're done. The rest, all of the infrastructure, the chunking, the monitoring, the refreshing is all managed by you as a service. So you can actually work on solving your actual business problems rather than trying to architect around the problems you're going to find.
You can also use Kendra now as an
yes,
too, which is kind of nice. So
yes.
if you use some of those older ML services that Amazon had and had a bunch of data in Kendra, you can just use that as an index.
Can you go back to that? And once you've created your model and the knowledge base, is there a simple service? I mean, I don't want to allow.
Yes. Yeah, no, you would not use it through the interface.
Testing standpoint, I think I can do that.
Yes.
Yep.
But
yep.
What other service can I integrate with this knowledge base that I've created so that my regular users, the accountants,
you can use the APIs of Bedrock to interface with your knowledge bases in several ways. First of all, you can associate your knowledge base to an agent and use the agents API, and we'll see that later. Or you can simply say, you can do a simple invoke. So there is a way of starting a conversation, so all the invoke for inference that you would use before, but you can now tell Bedrock, hey, complete this, give me an answer to this question, and look at this knowledge bases. And so as part of your call, you can literally send the prompt, the query your user has made, and the knowledge bases you want to use, and you're going to get back a response that is basically considering those. It will give you the references that it used to answer the question and the answer to your question. And you can simply now even say, you can simply tell Bedrock, hey, I have this question, give me my knowledge base contents that answer the question, and then handle that yourself.
And here is the console where you would do that. Mm-hmm. And so I just asked it for the bucket, and it listed a bunch of data.
Yeah, like for instance, now this is a console, this is not something that
yeah, no, you have APIs. And the key for the APIs is question through agents. So simply ask a question and have the agent work it, because agents can use both knowledge bases and tools. And then you have the other ability you have is saying, hey, answer this question with this model, with this temperature, this prompt, this knowledge base. Or you can simply say, hey, just give me the content of the knowledge base that answered this question. So you have three approaches. All these are done through APIs, so you can integrate in your own systems. Good questions.
So wanted to talk a little bit. This is a newer feature. I don't think it's like brand new, but it's a newer feature.
Yes.
Where you don't want your agent showing data that's privacy protected or data to the world that shouldn't be there. Such things like PII. You don't want your agent to swear at you. You don't want your, like you want to set some guardrails around your agent. And so in the demo, what I did was I was showing now I lost my window. I'll open a new tab. In my demo here, you can see we asked for the data and it showed social security numbers. I kind of did that on purpose because I wanted a demo. You can go into Guardrails, which is a new feature, and I can turn on many different types of guardrails. So I can have content filters. I can have topics we don't want it to talk about. We can add word filters, sensitive information, which this one is. So we can add grounding checks too to make sure that our model is not hallucinating. Yep. So this is a really nice feature to help keep your model within the world you want it to be in. Yes.
Good question. So the idea is these guardrails are applied at least twice in the execution of a model. First of all, they're applied to the input from the user. So the user asks a question. The prompt from the user gets sent to Guardrails and it goes, hey, does this question trip any of these filters, right? And again, these filters are very important because you have two different use cases, right? There is the non-malicious user that may just be asking the question to the wrong AI. Say, for example, that you have a chatbot that's supposed to answer a question on claims, right? And someone goes in and asks, hey, how do I remove an ink stain from my shirt? Yes, probably the model could be able to answer that, but it's probably not what you want to spend your money answering questions for. So the first filter there is user writes a question, it goes through Guardrails. Guardrails applies all of your filters, your reviews to make sure that that question is relevant to what you're doing. The other part is the malicious user, right? It's the idea of users that are trying to manipulate your chatbots, your AI interfaces to make them do things that they were not supposed to do in the first place. Again, the prompt goes in and one of the questions is this a malicious prompt? Is this prompt trying to make the model do something that it's not supposed to do? Once all those checks are done and your prompt is validated, it goes through the foundational model. So far, if that question is not relevant or it trips any of this, it doesn't even get to your foundational model. You get to the foundational model, maybe that model is getting something from the knowledge base, it will create an answer. And now that answer, before going to the user, goes through the Guardrails again. So you run the same checks. Is this grounded? Is this model being hallucinating here? Once it passes all the checks, then that answer is sent to the user as a response, to the caller of this as a response. So the model never sees a prompt that it's not being filtered, and the user never sees an output that is not going through the Guardrails.
And when you set them up, you set up an input and an output. So like I can allow social to be entered, but it'll mask it on the return.
For different knowledge bases, or is that more at the global level?
You define the guardrails at a global level, and then you can apply them to the different parts within Bedrock.
Yes. So basically what you can see, because you're still in control of calling the APIs, right? So whatever application you're developing. So when you make that call, you can tell Bedrock, hey, answer this question and apply these guardrails to it, right? So that's to make sure that you're in control of that. And you can pick different guardrail set based on the kind of, because imagine that you have several AI applications. Maybe you want different guardrails for it, right? Maybe for an applications that dedicated to your workers, to people that actually need to work with sensitive data, you may not want to mask sensitive data. For a public facing one, you may actually want to have the ability to say, hey, for this, mask that data. So you can apply guardrails, and that can be done at the level of the query when it's being made to say, hey, run this query, apply these guardrails.
So when you say the newer one, is the PII type and the
No, Guardrails is a newer.
The whole,
yes, whole system.
The Guardrails it came out of preview not long ago. It was in preview until a couple of months ago. and it's still being worked heavily on. We are at different, different filtering techniques. We mentioned about grounding, where now we started looking at automated reasoning, where you can actually have an automated reasoning process where you can verify that the answer that is being given matches some set of rules that are very heavily defined. So you can get the benefit of the generic model's answer, while at the same time applying rigid controls to the answer that it's given to the user.
So I'll demo Guardrails. I'll add it to that agent and it will ask for the data, and you can see that it should mask the PII data coming back. So if I go in here and I go back into the agent, we were playing with this customer data agent before. I can go in here and I can edit it. And down here, you'll see Guardrails. So we're able to edit, and I can add the SSN guardrail and save and exit. And then I will save and exit. And I will, where's the?
Looking for the test? Or?
No, that prepare button. Sometimes it comes up. I can.
Yeah, it should be ready to go though.
Let's
Sorry.
try it again. Yep. So there you can see the social security numbers are taken out of the response.
You mentioned that you can mask them too?
Well, that's
Yes.
That's what it did. The masking takes them out.
I can't see.
It's got names and addresses, but no socials anymore. The previous
Gave you the actual show on them.
actual
You just grab there.
socials.
But sir, the idea of guardrails is very important. And again, whether you use Bedrock guardrails or not, the pattern of guardrails, so the check the questions going in, verify the answer before it's fundamental to be implemented. Again, whether using your service, implement your own. Guardrails are very important because no one wants to be the next Air Canada.
Or that company that gave away a truck, didn't?
Yes, for $1.
Yeah. Another new feature that was announced at reInvent was the ability to take a larger model and use it to train a smaller model, and they call this agent or model distillation. So you're able to build a highly specialized model by using another model and then your data without having to fine tune every little parameter and go through all the little steps that it takes. It's literally a couple clicks and you're able to tune a model based on a larger model. And then when you're running that smaller model, it's cheaper to run than the larger model. And it's also trained and specific to your data.
Yeah, and I think the importance of distillation, so the way distillation works in itself, you have what we call a teacher model. Imagine a large model like, Claude from Anthropic. You may be using a Sonnet. It's a very large model. Or if you think of open source models, like for example, you may have a Llama model that has 400 billion parameters. That model knows everything, right? It has seen a lot of information on everything. You can ask that model, hey, what color is the outside of the St. Petersburg Museum? And it may give you an answer. And that's why it's so large. But the reality is, if you're thinking of a model that you want to use to answer questions on your specific business, right? maybe that model doesn't need to know about how big, what's the color of a museum in Russia. The idea of distillation is saying, hey, you know what? Instead of having these large models, we can have a smaller model that has less parameters, that is less neurons, as we said. So a smaller brain, but it's specialized on things that we want to know. And so you can take the larger model, and the larger model can use your existing data and can generate the training data for the smaller model and basically create a feedback loop in that smaller model and training it on your specific data set. So on a smaller set of subjects than the larger one. And now what you get out of that is that you can keep a lot of the reasoning capabilities in the smaller model, but eliminating all of those facts, all of that parametric memory that it doesn't really help that model give the answer you want, right? So you have a smaller model that's faster to run, so it has lower latency, better experience for your user, and it's cheaper to run. Just because you now have a model that has been trained on the specific domain it needs to work with.
You generate the training data out of the.
Yes. The idea is that you have the larger model, you can give them think about it in terms of, for example, one of the techniques is synthesizing data, right? So you can say, hey, as we said before, you usually don't have, compared to the amount of data these models have seen, you may not have that much data. So what you ask the large model to do is basically, hey, look at this data and now generate training data for this smaller model based on the data you have. And so you can use the smarts of the large model to create that data and to transfer some of the parameters from the larger model to the smaller one that belong in the areas of interest you have.
You have to provide it a training set of your data that you're
Yes.
training on.
Okay.
But you have you point to a teacher model and
Yes.
then a student model, and your data set are the three-legged pillar, I would say.
Yes.
So you're not creating a new student model.
No, the student model itself, you're fine-tuning the student model. And the idea is that what you're doing partially is knowledge transfer between the larger model and the smaller one. And part of it is synthetic data generation, where you can see where the larger model gets activated on your documents and transfer that information to the smaller one. The way I explain it, to keep it simple, is simply saying your larger model can look at your data and teach the smaller model things that are relevant to the data you provided to it, right? So eliminating all the stuff that it needs. A model that needs to answer, is my fender bender covered by my policy? Doesn't need to know about what's the capital of Italy, right? Italy.
Well,
Rome.
Italy.
You're hallucinating.
So yeah, one of the demos I saw on this was really cool. They took a large model and they trained a smaller model on like electrical engineering. So it's like a highly specific field.
Yeah.
Right. And then it didn't need all that data like Fabio was mentioning, but it knew a lot about electrical engineering, and you could ask it very, very specific and detailed questions about electrical engineering. So another newer feature, I guess, is agents. We've kind of demoed this a little bit. That you take a knowledge base, and you don't even need a knowledge base. You can just actually hook an agent up to a foundation model. But using a knowledge base, you can implement RAG. A newer feature now is there's called action groups. So you're able to call and interact with lambdas and call APIs within your enterprise based on what you're sending to the model as prompts.
Yes. And again, when you think about models, I always tell people, you have to imagine models are brains in a vat, right? So they have very limited ability to interact with the outside. So what all these things we're trying to do, right? Think about tool calling, the ability to integrate with knowledge bases, is giving these brains a way to interact with the outside world, right? So in itself, the model is not going to call any of this tool. What happens is the model says, I know these tools because you told me. Again, I can't call those APIs, but I can ask the caller, hey, call this tool with these parameters and send me back the results. This is usually how most of this interaction works. So if you have not been living under a rock and you're interested mildly in GenAI, you may have heard of MCP, the Model Context Protocols. They're all ways of giving tools to the brains in the vat to interact with the external world. And the way they interact is saying, hey, can you call this tool with these parameters? They get the answer back and they take the next step and they go, okay, now I know this and I can move to the next step, right? So when we talk about agentic, think about agent to agent, MCP, agentic model. It's all about this. It's all about saying, how do I allow a brain in a vat to interact with the world outside it? And as a side note on this one, you understand that the moment you allow your models to interact with data and external systems, it becomes critical to have guardrails in place. Because an hallucination when answering the question about, what's the oldest church in Sulmona, Italy, right? You hallucinate, who cares? You give bad information, someone is not going to pass his major in Italian arts. But if by mistake you give the wrong medicine to someone or the wrong medical recommendation, or you deny a claim to someone, or you allow someone to buy a car for $1, the consequences are bigger. So as you integrate with external system, guardrails, one form of guardrails becomes even more important.
And so I'll give a quick demo of this. One of the things, so what I can do is in my agent, I can go in here and I can add what's called an action group. And so an action group can either be an API call or a Lambda function. And then I provide it a Lambda function and what are some of the parameters I want to pass into that function in their description. And then when the model is invoked and it needs to look something up by social security number, it's able to go in and call that Lambda, and that Lambda is then able to read data in my data center or enterprise. And I can show you real quick what the Lambda looks like. They're very, very simple. They get the parameters here. And then in this case, I'm looking up in a DynamoDB table, grabbing a key based on that, and then scanning and returning that response. If they pass in one, if they don't, I can return all items. So I'm just controlling what I'm doing based on the parameter. As Fabio mentioned, guardrails are super important. You wouldn't want to leak that SSN, right? You want the data associated with it, but not the social security number itself to go back.
Agents, can you connect agents to, can you orchestrate across agents?
You're stealing my thunder. I'm just kidding. The question was, can you orchestrate across agents? Agent flows, new feature. So you are now able to create flows and interact with Lambda, additional AWS services. You can have agents make decisions on what other agents to call. So I see the benefit of this. When I was putting this together, I was like, can you imagine if you're an insurance company and you have a team that deals with policy data, one that deals with claims data, and one that deals with customer data. And those teams of developers, you want them to be able to tune and work independently and work on their own model, but you want to expose all of that interaction out to your customer service agents with all the security and everything related to it. you're able to use something like agent flows and coordinate all those calls and let the teams be independent on how they work on their own models, and they're responsible for their own data. So there is inside of Bedrock, go back. Inside of Bedrock, there are now flows. And we can see all the different things you can do. You can prompt the user for data based on conditions on what the user sent. You can decide if you're going to call different agents. Maybe you're looking up data in a knowledge base. Maybe you're going to call a Lambda function. So I can coordinate all this stuff. Right now, there's, I can even hook up to AWS Lex. If you're familiar with Lex, that's their chatbot service. Yep. So I can basically compose all of these flows with multiple agents working together. Does that answer your question?
That does.
And again, just to clarify, this is one of the many ways, right? For example, I believe end of last week, we announced one of our open source projects called Strands, which is just a way of orchestrating tools and agents released as an open source. MCP is a way of having multi-agents working together, agents to agent protocol. So there is we're in the period where if you shake a tree, you're going to find 20 Gen AI patterns, right? The question to me, I always tell people, is how much effort you want to put in implementing a pattern, or just the ability to use the pattern just as a Lego block? Because again, you may be more focused in, I need to solve a business problem than, I want to make the coolest agent platform for my business.
When I was working on this, I was thinking, this is how we go from monoliths to microservices to we expand our reach of our architecture. I wouldn't start with an agent flow because there's a lot of complexity with that and how you wire it up and all the prompts work between it. If I were to start simple, I'd start with the simplest thing I could think of, which would grab a foundation model, see if it works for you. Do you need to add your data? Then think about what that means.
Did you create these flows from the console, or was that like a?
I did it from the console.
Yeah.
You can do it.
You can do infrastructure as code.
Yeah.
Yes. Now, it's funny because this morning, while I was talking to other people about all the ways we have devised to connect this foundational models, this Gen AI models to the external world, it just dawned on me that most of the sci-fi movies we have seen growing up were about how do we prevent a very large intelligence from connecting to the internet and all the disaster. And literally, in reality, the first time we had a large model, the first thing we did is like, you know what we need? A way to plug this to the interwebs.
Have I lost all my questions?
No.
No, go ahead. No, I mean, this is, otherwise it's boring.
One more question. Now, when you have in your knowledge base, you can hook your SharePoint site or SD bucket. Is there an agent or is there a tool that can hook to CloudWatch itself? So if I want to get data.
Oh, yes. It's Q on the console.
Yeah.
Q on the console
Yeah.
can actually answer questions about your CloudWatch thing. Well, so
Connect to knowledge base?
well, we have Q for Business that connects to the knowledge bases you can create. So do we have Q for Business?
That's the one. Yeah.
Yeah. So we'll get there, but it is, for me,
I think I should shut up then.
No, you're fine.
there is a very, so if you have used Q in the console, in the AWS console, you'll find out, my recommendation is go and play with it, because the ability to do in-depth analysis on what's going on with your system through Q. I mean, generally people have used Q in the console to ask questions, say, hey, how do I do this? The reality is Q in the console as the context of your role and your systems and the accounts you have access to. So you can actually ask questions like, hey, why can't this Lambda talk to that database? And Q is able to chain together the flows, the network analyzer, and give you an actual actionable answer where it tells you, hey, that Lambda can't talk to that database because there is no security group that allows it to connect on the port.
It's phenomenal. We used it at a client site. We were helping set up a VPN, and there's some complexities with VPN networking. And we just went in the queue and said, why isn't this connection working? And it's like analyzing VPC, analyzing subnets, and then it just lists. It's amazing.
And there is a lot of work that's being done because so right now, mainly it works on your metadata, right? So Q in the console doesn't actually have access, for example, to your CloudWatch logs, right? It can't read them, but there is work being done in that to allow it to be even more powerful, where you can actually ask questions like, hey, what's wrong with my website? And Q is able to look at the logs and answer exactly what's wrong with your website.
It doesn't Q then have intelligence in the logs where it shows you like if the system is not behaving normal.
Yes, but that's it's in CloudWatch as part of the monitoring, is the smart monitoring, but we're trying to add more to it to give you the ability to do full investigation. So I think that the vision for Q in the console is that it literally should be able to open tickets proactively when there are things that don't work, tell you what actions he has done to determine what the issue is, and give you instructions on how to fix them proactively. So you don't even have to go and ask. You will literally get an email and ticket opened by Q that tells you, hey, dude, there is something wrong with your systems. This is what you need to do to fix it.
So I showed the agent flow on the screen. We have, you can write data to Dynamo via Lambda. I want to talk about Amazon Q for Business. I think this is awesome.
Yeah.
Because you're able to very quickly, and I will give a demo of this, you are very quickly able to get stood up with the Gen AI solution with a few clicks of the mouse. So if I go in here and go to Q for Business, I can literally create an application and I got a group here and I can go in and click create. And it's going through and creating an application. It's tying it into my IAM identity center that's already set up. It's reading my roles from our IDP. So now I can go in here. It deployed it to a URL. You could use our own URL. It's logging me in through my IDP, knows I have access. And so now I have a generative AI solution for my company out of the box, running on a model with a couple clicks.
And that's connected to your knowledge base that you have created.
Right.
You can attach it to your knowledge bases, external system, the integrations you get out of the box with Q for Business. Where is it?
Oh, no, it's
You should, yeah. But basically, you can create your own applications here. If you click to plugins, I think you should have up here.
Oh, yeah. So
these are the current plugins we have. So the idea here is that now you can connect directly with Asana, Confluence, your calendar, your email, and pull in information. So your business users can start creating applications that leverage connections to your data, to your applications, to solve specific work problems. And the best part is that they can share that with other people in your same company. Saying, say that someone has created an application that says, hey, every time there is a meeting request for this person, ignore it and create a fake application, a fake meeting at the same time. I don't know why you would do that. It's just that then everyone else can simply use the same application, right? And now you have a proactive application, and whenever you get an invite from that person at a given time, it will, say decline and create a random meeting at the same time. Oh, sorry, can't make it. But so these are, if you think about it, you can now empower business users to create their own applications at this level. So we have seen today how, as usual in AWS, what we normally are we have done for many years, we have done building the simplest Lego bricks, and now we started working with Gen AI to give access to higher level Lego bricks, right? So you can go all the way, I need to invoke a model, right? And run the best of breed models that are out there right now. But at the same time, now you have a way for your developers through Q Developer to use intelligence, for your business to use Q for Business to extract the benefits of using these large language models. And so we're trying to cover the usage of all of the different roles in the company, in the enterprise, to use Gen AI to their advantage.
So some takeaways and next steps. AI is constantly changing. A lot of this didn't exist 6 months ago, 3 months ago. So it's constantly evolving. AWS is the building blocks for your business. As a partner with AWS, LT is an advanced partner. We're here to help you and your business make use of these tools, and then reach out to us. There's a QR code on how to get connected to us.
Smack on time. Thank you. Thank you, everyone, for joining us.
Thank you.
Are there questions from the chat?
Yeah, there's a couple of questions in the chat.
Okay, there are a couple questions.
Yeah.
Is Nova working on improving reading files? To analyze CSV, and it struggles what files of more than 50 rows.
Yes, so you're probably are hitting issues with the context size, though 50 rows seems very low. Daniel, let's talk about it, because I'm curious to see the specific use case. There shouldn't be out of the box issues with CSVs because they're text to text. I would have been it. I think that for some, first of all, which Nova model are you using? We have 3 different sizes. Nova Pro, only 50 rows is struggling. I'll send over to you. I'll try to see if I get your email. I can.
If you connect with us and get us your contact information, we'll.
Yeah, because I'm curious to look at the specific case, because it hasn't been my experience, but I always feel like I'm gaslighting people if I say, no, I haven't seen that. So I want to see what the specific case is. I'll try to reach out. You can reach out to us and work on it together. Thank you for the question, though.
Yep. All right. Thank you, everyone, for attending.